We're going to talk about mutually exclusive events. And when we're doing this, we're going to multiply our events together. And in this case, I'm going to show you what happens if I don't replace, so a deck of cards, I take one out and I don't put it back. So the first one, probability of a king. Well, there's 4 kings out of 52, followed by a queen. Well, there's 4 total queens, but if I don't put it back, I'm now looking at 51 cards in my deck. So when I multiply that, I get 16 over 2,652. I could reduce that, but I'm not going to because when we're talking about probability, we're using a decimal. So when I take this decimal, 16 divided by 2,652, I get 0.006. And there's my first answer. The next one, the probability of a king. So again, we're dealing with 4 out of 52, followed by another king. Well, if I don't replace that, the first thing I know is that there's 51, and there's only 3 kings left, followed by a 4. Well, there's 4 4s in the deck, but now there's only 50. When I multiply those all the way across, I get the following fraction, but I'm not going to reduce the fraction because I want it in decimal form. So when I take this into decimal form, I get 0.0045 as my final answer. Last one, we're talking about a dice here. I roll a 1 followed by a 5. So on a dice, I have 1 out of 6. Then I roll a 5 on the second, which is 1 out of 6. When I do this, I get 1 out of 36. 1 out of 36 is not my answer. I want the decimal, which is 0.0278. And a lot of these are asked around 4 decimal places.